Next, we'll discuss the percentiles under the normal curve. Our previous discussion started from a random variable x, and then we converted it to z, and then we find its probability or its area. Now, we will start with the probability or the area, and then we will find its z. Afterwards, we will convert this back to x. So one of the example in finding your z from an area or from probability is these percentiles under the normal curve. Now, what is a percentile? So in statistics, a percentile is a term that describes how a score compares to other scores from the same set. While there is no universal definition of percentile, it is commonly expressed as the percentage of values in a set of data scores that fall below or equal to a given value. If your teacher tells you that your general mathematics grade of 93 for the first quarter is at the 90th percentile, this means that 90% of your classmates scored lower than or equal to 93. So if we have here, we have the 90th percentile, and your score, the value here is 93, or your grade. Okay, so if you receive a 90th percentile for your grade 93, then it means that you outperformed 90% of your classmates. Okay, and this is just 10. Okay, so this is typo. So 10% scored more than 93%. Scored more than your grade 93. So this explains that 90th percentile is located at a point such that 90% of the total population lies below or equal to that point, and 10% lies above that point. So now let's have this finding the z-scores corresponding to percentiles. Find the z-scores corresponding to the following percentile. Number 1, the 86th percentile. So when we draw the normal curve, so the 86th percentile, it means 86%. So take note that half of the normal curve is 50%, right? So since this is 86%, so 86 minus 50 is 36. So we're left with 0.36 here. So therefore, this is the 86th percentile. So we're asked to find the corresponding z-score. Now in this case, if our percentile is greater than 50, we will focus our attention on the excess. So the excess here is 0.36. Okay, so since this is an area, so we will start here at the center. So let's look at 0.36. 0.36. 36. Okay, 0.36 is between these two. No, not that two. These two numbers. So 0.36 is here between 0.359 and 0.3621. So these two. Okay. So it's just like this. So I will write 0.36 here. So I'll just add 2 zeros. Okay. So on the left side of 0.36 is 0.3599. And on the right side is 0.3621. Okay. So we'll just choose which of these two 0.36 is nearer. So for others, they can see directly that 0.36 is nearer to 0.3599. Okay, but for others who cannot see it directly, then just take the difference. So meaning just subtract. Okay, so our subtraction is like this: 0.36 minus 0.3599. So the result is 0.0001. So this is their difference. Now these two, their difference is 0.3621 minus 0.36. So 0.0021. So since we will choose which of these two is nearer to 0.36, then of course we will choose the smaller difference, so which is 0.0001. So therefore, we will take the z value of 0.3599. So 0.3599, which is this one, has a z value of 1.08. So z is equal to 1.08. And since it is on the right side, so it is positive. So our final answer for this percentile is 1.08. Next, P95. So again, draw the normal curve. So we have 0. So we have 50 here, 50%. And of course, our excess is 95 minus 50 is 45%. So this is now the 95 percentile. So again, the z here is positive since our percentile is greater than 50. So our focus here is 0.45. So let's add 2 zeros. So let's find 0.45 here. So it's between these two numbers. Okay, 0.4495 and 0.4505. 0.4495 and 0.4505. Okay, so taking the difference, this is 0.0005. These two also has a difference of 0.005. Now take note, they have the same difference or distance from 0.4500. So what do we do here? We will take the average of their z-scores. So this z-score for this one is z. So let's have z sub 1, which is 1.64. And the other one, which is z sub 2, is 1.65. So our final z here is just the average of these two. So 1.64 plus 1.65 divided by 2, because there are only two numbers. So the result is 1.645. Do not round this off because we are taking the average. Okay, and z is on the right side, so it's positive. So therefore, our final answer is 1.645. Okay, next. So this is now an example of a percentile which is less than 50%. So let's draw. Basically, we will do the same thing, but it's just on the left. So 0.32. So it is not above 50%, so somewhere here. So this is our 0.32 or the 32%. Okay. Now in this case, if the percentile is less than 50%, we will not directly look at the table and find 0.32. First is we need to find the area here because this will be our focus. Why? Because this area from our table is based on the center or based at the center. Okay, so that is why we need to focus our attention on this area. So that area is 0.5 minus 0.32. 0.32, so which is 0.18. So we'll focus now on 0.18. So I just add 200. Okay, 0.18. So where is 0.18? So it's between here. 0.1772 and 0.1808. So using your calculator, this is equal to, or the distance or the difference is 0028, and this one is 0.0008. So obviously this is smaller. So we will choose this Z. Now this Z is 0.47. Okay. So this is 0.47. Now, is this our final answer? No. Why? Because take note, our Z must be a negative number because it is at the left of 0. So therefore, our final answer for Z is negative 0.47. Okay, next, we have the 15th percentile. So 15th percentile. So again, this is less than 50. So this is the 15th percentile, or the 0.15. So again, we cannot go directly to our table and find 0.15. Instead, we'll focus our attention on this area. So we have 0.15 minus 0.5, I mean 0.5 minus 0.15, which is 0.35. So 0.35, we'll focus our attention on 0.35. So 0.35, where is 0.35? Okay, it's between these two numbers or two areas. 0.3485 and 3508. So take the difference. This is 0.0015 and this is 0.0008. So the smaller difference is this one. So therefore, we will take this. Now the z-score for 3508 is 1.04. 1.04. Now, since this is on the left side or at the left side of 0, our final answer is negative 1.04. So this is the corresponding z-score of the 15th percentile. Okay, let's go now to problem solving. Emotional quotient or EQ score on the latest version of Sirug EQ test are performed so as to follow a normal distribution with a mean of 110 and a standard deviation of 15. Find the 96th percentile of the distribution of the emotional quotients. So this time, after we find the Z or the corresponding Z score of the 96th percentile, we can now convert it back to X because we're now given with a mean and a standard deviation. So let's find first the 96th percentile. So I hope you can find it on your own. So a 96th percentile. So our focus here is on the 46 because this is greater than 50%. So 96 minus 50 is 46. So our focus is on 0.46. Okay, so 0.46. Where is 0.46? Okay, here. So 0.46. So by just looking at this, I hope you can compute the difference between the two. So it is clear that it is nearer to 0.4599. Okay, so this one. So therefore, we will choose this. And the z-score for this is 1.75. So the corresponding z-score for this is 1.75. Now, take note that our equation for z is x minus mean over the standard deviation. By formula transformation, to solve for x, it is just equal to the standard deviation times the z-score plus the mean. Okay, so this is a fixed formula. So now let's substitute. What is the standard deviation? It's 15. What is the z? It's 1.75 positive because it's more than 50%, the 96th percentile. Then we have plus 110. So please use your calculator. So 15 times 1.75 plus 110. So 136.25. So it means that 96% of the people have EQ below or equal to 136.25. Okay, additional word problems, wherein we will start at the area and find the z and then find the x. So to qualify for a master's degree program in business administration at San Sebastian College, candidates must score in the top 20% on a mental ability test. Okay, so top 20%. So where is the top 20%? Is it on the left side or the right side? So top, it means here on the right side. So this is the top 20%, or the 0.2, 0.20. Okay. The test has a mean of 180 and a standard deviation of 25. Find the lowest possible score to qualify. Assume that the test scores are normally distributed. Okay, so by just looking at this illustration or curve, we know that if we find the z here and convert it to x, this is now the lowest possible score of this top 20%. Okay, because if you look at this, it serves as a boundary. Again, so since this is a tail and this area here is not at the center or connected at the center, we will not focus our attention on 0.2, but instead we will focus our attention on this part, which is 0.30. So this is just 0.5 minus 0.20 equals 0.30. Okay, and then so we will focus our attention to this. Then 0.30, find 0.30 on the table, on the area. So it's between these two numbers. So using your calculator, you can find the difference. But for others, I'm sure you will agree with me that it's 0.2995. 0.300 is nearer to 0.2995. So the z-score or the corresponding z-score for this one is 0.84. So since this is on the right side, so it's positive. So our z is 0.84. So we will use now our, so we have this formula, mean. So we have sigma z, or the standard deviation, is 25 times 0.84 0.84 plus 180. What is this equal to? 201. So the lowest possible score to qualify for a master's degree program in business administration at San Sebastian is 201. This is the lowest possible score. Okay, number 2. The price of the new condominium unit in the Bonifacio Global City is normally distributed with a mean price of 85 million and a standard deviation of 920,000. Find the minimum and maximum price to attract the middle 90% of this market. So middle. So let's draw the normal curve. So meaning middle, so it must be symmetric. So we have negative z and positive z. So this is our area. So middle 90%. So let's divide this by 2. So 90 divided by 2 is 0.45. So meaning one side, or on the left side of the mean is 0.45, and on the right side, the area also is 0.45. By symmetric property, we can focus only at 0.45. Okay, so 0.45. 0.45 is where? Okay, this one. Okay, 0.4495 and 0.4505. So in this case, these two areas here have the same distance to 0.45. So meaning we'll just take the average. So the average is 1.64 plus 1.65 over 2. So we have 1.645. So meaning the positive z here is positive 1.645, and on the left side it's negative 1.645. So this z, this positive z, will correspond to the maximum price, and the negative z will correspond to the minimum price. So let's start with the minimum. So let's have x min. So the standard deviation is 920k. I'll just write k times the z, which is negative 1.645, plus the 85 million. So a total of, please use your calculator, negative 1.645 plus 85 million. So we have 83. The minimum price is 83,486,600. And for the maximum, you have 920,000 times 1.645 plus 85 million. So this is equal to 86 million 513,400. So the minimum and maximum price to attract the middle 90% of this market is 83,486,600 and 86,513,400 respectively. Next, test score for the Manila Science High School are normally distributed with a mean of 92 and a standard deviation of 13. To qualify, the candidate must score in the top 10%. Find the lowest possible score to qualify. Okay, so let's draw the normal curve. We have 0. 10% is here. Top 10%. So again, we will not focus our attention on point 10, but we will focus our attention to point 4 or point 40. Okay, this is 0.5 minus 0.10, which is equal to 0.4. So the corresponding z-score for this is 0.4. Okay, we have this. This is between these two areas. Okay. So it's nearer to 0.3997. So therefore, our z here is 1.28. 1.28. So it's positive because it's on the right side. It's at the right side. So therefore, our x here is, the standard deviation is 13 times our z, and the mean is 92. So you can use your calculator. So the answer is 108.64. So the lowest possible score to qualify is 108.64.